Hi, my name is Benjamin Behar, and I'm presenting final project, which is multi-fluid simulation. My group is composed of myself, Benjamin Behar, and my partner, Alex Dahl. We implemented I believe it's called a semi-Lagrangian fluid simulation, which is a combination of both a grid and particles. We chose to do this because it can be a little bit more accurate description of how water interacts. And we chose to extend this kind of simulation to use multiple fluids based on the individual particles. Um, anyway, here's our simulation. A few things you can do to it is you can click and drag, and it pulls the fluid with you, which allows you to disturb the water and see what happens. So, for example, you can see the waves forming. One thing worth noting is that when I pull this up towards the top, another feature that we had was the water or fluid starts to stick to the top of the simulation due to the velocities on the grid at the borders equaling 0 so that nothing will leave the simulation. That is an unintentional side effect, but we really liked it, so we played it up and made sure it worked and looked pretty. So anyway, more user controls are you can press plus and minus on the number line to shrink and enlarge the size of the particles. This is useful for watching motion. For example, if you click and drag and swirl the blue water, and then you can see the motion pretty clearly, but if you enlarge them, you really can't unless these little black particles are going with. So we added that feature just so you could see what's going on. If you press Q, you can see the pressures of each cell. And high pressure is red, and low pressure is whiter, and then it becomes blue when there's very little pressure. And so that shows how the fluid is interacting with each other. And now, we also have created, let me turn these off, two simulations. This first one that we're looking at right now, I'm going to press 1 to reset it, is oil and water. The oil is made of particles that are at 0.5 density, and the water is all particles that are at density of 1. And then this second simulation, if you press 2, has water at about the same density, but it has the black oil at a much lighter density. I believe this one is 0.1 or 0.01. And as you can see, it reacts very differently than the first one, and that's because it has less mass to keep it in place, and a much higher density, which allows it to push harder down on the water. Now, this is my favorite simulation because this looks very similar to foam, in my opinion, when you see waves crashing and such, and that got me very excited. So let's play around with this foam one a little bit more. So another cool user feature is that you can press space to spawn little pebbles that fall from the ceiling and fall through the simulation, spreading apart the water or the liquids, and then flowing to the bottom, carrying along stuff with them, as rocks normally do when you throw them into water. Now, in this particular simulation, you notice that they cut through the foam rather easily, but then are stopped very quickly by the water. And that's because in this simulation, the foam is very low density and the water is very high density. Now, if we go over to the other simulation, we'll try to stop it from being all dramatically sloshing by clicking the mouse and holding it still. It takes a little bit of the energy out of the simulation to tell it to have a vector of 0. So if I press space now, you'll notice that it cuts through both pretty easily and leaves behind a little gap behind that's filled by oil. And you can see that flow better when I shrink the particles and turn on the density. So let's add one here. It falls down, and you can see all the particles being pulled down and then sloshing away out to the sides. And you watch as circular currents are created in the water because of that initial displacement. So because this is a fluid simulation and we want to show how amazing it is, I'm going to slosh it all around. And I'm going to say thank you for watching and have a Merry Christmas. And I hope you enjoyed our work. Thank you.